Hey guys, Mr. T here. This is another video. This one is on perfect squares factorization. So we've seen an expansion that if you've got the perfect square a plus b squared, if you expand it, we get a squared plus 2ab plus b squared. So we used and practiced using this shortcut to expand anything in that form. You also had some practice if the perfect square was a minus b in brackets squared. If you expanded that, you would get a squared minus 2ab plus b squared. So if they were minus to the a and b in the brackets, the only difference between the expansion would be it would be minus the 2 times the product, okay? So you can actually use these expansion shortcuts backwards to factorize some quadratic expressions. So if you've got a quadratic that looks like this and you want to put the brackets back, which is useful in some cases in some of the later maths that you need to do, then you can use this rule in reverse. So basically the steps involve, look at the constant term, so the number term in the quadratic that you've got. Check if it's a perfect square, so like a nice round number that you get a whole number square root. So 4 is a perfect square because the square root of 4 is 2. 9 is a perfect square because the square root of 9 is 3, and so on. Okay, so check if the constant term is a perfect square and find the square root of that constant term. Step 2, identify the term with the variable to the first power. So there's always going to be a term where you've just got the variable, say x, by itself, not to the power of 2. Usually the middle term, but the order doesn't matter. So for example, 8x. Now if you divide that by 2 and the square root of the constant term that you found in step 1, see if the result is the square root of the leftover term. So the square root of the leftover term being the one that's the variable to the squared power, so x squared. If both 1 and 2 are true in the steps, then you can use this perfect squares factorization shortcut here. So that second step there can be a little confusing if you're not the best at algebra, so I'll try and show you what I mean by that in the example here. So step 1, look at the constant term and see if it's a perfect square. 100 is a perfect square because the square root of 100 is equal to 10. Step 2, look at the term with the variable to the first power, so this one here, 20m, because m is to the power of 1, divided by 2 and the square root of the constant term. So 20 times by, that's what that is, divided by the square root of the constant term and 2. So 2, that would come to 10m, and then divide it by the square root of the constant term, that would come to m. If both 1, and then you check to see if the result is the square root of the remaining term. So the remaining term is m squared. What's the square root of m squared? That is m, because the number that you're squaring to get m squared is m by itself. So if both 1 and 2 are true, which we found here, then you can use perfect squares factorization. You notice that this is a minus, so it must be the minus version of the shortcut, this one here. So our a in this case is m minus, and our b in this case is the square root of the constant term, which is 10. So m minus 10 squared. Okay, so we've got to the factorization straight away just using the perfect squares factorization. We can check if that's true by expanding this out. So m take 10, m take 10. What is that using FOIL? M squared minus 10m minus 10m plus negative 10 times negative 10, 100. M squared take 20m plus 100 So you can see that reverts back to the expansion, so we can confirm that this perfect squares factorization worked. Okay. Sometimes, however, you're going to need to do a couple of steps or do a simple factorization beforehand. So right now you'll notice that this is not a perfect square here. Okay, but you also notice that all of these three terms are divisible by 2. In fact, they're negative numbers, they're all divisible by -2. So you can remove the common factor of -2 from all of these. So what would I have to times by -2 to get -8x squared? 4x squared. What would I have to times by 2 to get -24x? Positive 12. X. And what would I have to times by -2 to get -18? Positive 9. Now you'll notice that we have three terms, and the constant term is a perfect square. The square root of 9 is 3. So let's apply our perfect squares factorization steps. Divide the term with the variable to 1 power by 2 and by 3. So 12x divided by 2 is going to be 6x, and then 6x divided by 3 is going to be 2x. Now we have to check if this 2x is the square root of 4x squared. How do I do that? Well, I can check by going 2x and squaring it. That becomes 2 squared times by x squared and 4x squared. So 2x must be the square root of 4x squared if 2x in brackets squared comes to the same thing. So now we know that a is, and because this is the positive sign, we know it's the positive perfect squares factorization. So we know a is 2x from here, and we know that b is 3 from here, and it's being squared, and we remember that we removed the common factor of -2 at the front. So that is applying the perfect squares factorization to get to the answer quicker. Okay, we can show that this comes to this using FOIL. So here we go, just to double check. 2x plus 3, 2x plus 3. So we're not doing anything with the -2 at the front to start off with. First, 2x times by 2x is 4x squared, plus outers, 3 times by 2x is 6x, plus inners is also 6x, plus 3 times by 3, 9, -2, 4x squared, plus 6x, and 6x is 12x, plus 9. And then times out the -2 with everything, so -8x squared, -24x, -18. So you can see that this expression with the brackets, with the perfect square in it, but it's multiplied by -2, actually results in the same as before. So we've done the factorization correctly. So that is a more complicated example of using the perfect squares factorization to factorize an expression. Hopefully that helps you out, and I'll see you in the next video.